Quiz 1. I hope this works out. This is a brand new quiz that I never gave before. What's the current running through this 5 ohm resistor? Well, I'll label downhill. Oh, if from here to here is 8 volts, how many volts from there to there?
8.
Knock, knock. So now that I know that that's 8 volts, I can also tell you that the current up there is going to be 8 divided by 5, which is 1.4? 1.6, that's what I said. So how many amps are going through... Oh, I'm done. What if they'd want me to find the current in R2? How many amps are going through that one? Can't be 1.6. 0.4? So I could have also asked you to find the resistance of R2. Now that I know, or the power in R2. If I know 2 things, I know 4 things. Okay. Which of the following is correct? The voltage and current are the same for all 3 bulbs? No. Now, all these bulbs are identical. So if you wanted to, you could make up nice numbers, and we may handle that in a second. In fact, I had one of my students, they did this. They said, Mr. Dewick, I let the battery be 120 volts. Why 120? Because lots goes into there evenly. And then I think they decided to let this be 10 ohms, 10 ohms, and 10 ohms. Now, I do know that this is 120 volts, which means how many amps are going through Z? Okay. How many amps are going through that? I don't know. Or do I? If I made this 1 resistor, how many ohms is that? 20. And how many volts are flowing through that 20? So I could say the current flowing up there is going to be 120 divided by 20. Which is?
6.
Okay, so this is 6 amps, 6 amps, 60 volts, 60 volts, which makes sense. They're identical resistors. They should split the voltage. Okay, the current in Z is less than the current in X. That's wrong. The current in Z is greater. I think that's right. Yeah, you know what? C.
No.
Now, with numbers, that works, but could you have done that intuitively? Yes. But if you're not sure, Sarah, don't be scared to stick numbers on there. I do that if I'm not sure, especially on a test or a quiz. All right. What's the total current leaving the battery? Labeled downhill. I'm starting right there. I can probably do this without rewriting the circuit. You could, but as soon as they give me 2 things, that's usually the crack in the armor, and I can usually then take it from there. Because if I know that, I also know that the current here is 8.5 divided by 60. 0.14166. Because I'm going to use this, I'm going to carry some extra sig figs, so I'm going to write 0.14167. Oh, also, how many volts from here to here? How many volts from here to here? This has to be 8.5 volts, which means the current flowing through that one is going to be 8.5 divided by 40, 0.2125. And I'm pretty near home, because now, what's the current flowing in this 10? What's the current flowing in this 25? What's the current flowing through the battery? I think it's going to be those 2 combining right there. So it's going to be that number plus 0.2125. You get 0.354. I'd take 0.35, but I'm going to probably use this, so 0.354. So I total is going to be 0.354 amps. If you got that, I would give you 3 out of 3. Otherwise, I would probably do something like this. I would probably give 1 mark if I saw that. I would give 1 mark if I saw that, and I would give 1 mark if I saw that. So make sure when you find something, you label it on the diagram where you found it. That's what I'm looking for. I won't need to see V over R, although if you want to write that, you can. What did part B want me to find? Voltage of the battery? Okay. So now that I know that this is 0.35445, Mr. Dewick, 0.354, did it again, 54 amps, and this is also 0.354 amps. I think I'm going to ski, and I can ski that run, or I can ski that run. Because I have this as my answer button, wherever I see a 0.354, what am I going to type instead? Answer button. So what's the voltage in this upper resistor here? It's going to be 0.25 times answer button. Sorry, not 0.25, 25. Where'd the decimal come from, Mr. Dewick? 25 times answer button. I get 8.85. Oh. I want that number back again. How could I get that number back again? I went 20 feet. Well, you know what? Let's be really lazy. I'm going to backspace a couple lines. Plus 0.2125. I've got that lovely decimal back again. I can multiply it by 10 in my head. It's going to be 3.54. Is that right? What's the total voltage? How will I figure that out? Yeah, in fact, if I was doing part B and I wanted to be dead on accurate, I would probably have gone like this. 25 times answer button plus 8.5 plus 10 times answer button. I times R, and that voltage I know. Do you get 20.89? You know what, 20.9? Is that right? Yes? No one moving there? Is that answer for B? Back row is just completely still. Okay. Completely still. If you got the correct answer then, so V total is 20.9 volts, I would give you 4 marks. Otherwise, I would do something like this. If I saw that voltage there, I would give you 1 mark. If I saw that voltage there, I would give you 1 mark. If I noticed somewhere that you had put I total on the diagram somewhere, I'd give you 1 mark, and then I'd give you 1 mark for the answer. Something like that. Next page. Power loss. We'll see if this works. I took an old question and I changed the numbers, and sometimes that means I make up impossible circuits, but I'm hoping this works. I'm starting right there. And you'll notice on both of our circuits, we did not have to rewrite them. You're going to get another take-home quiz today. You will have to rewrite them by going 1 over R parallels 1 over plus 1 over and reducing it to its simplest form. But I'm starting right there. I'm going to label downhill. I know 2 things. I know 4 things. I definitely know the current. Current is going to be 6 divided by 4.5, 1.33333. Oh, and 9 ohms. I think this is also 6 volts, yes? Because from here to here has to be the same voltage potential difference. So I can tell you the current there, it's going to be 6 divided by 9, 0.6666. Is that right? So I total, is I total exactly 2? Right, if I go that plus 1.33333333, I think it works out to exactly 2. Well, that's kind of convenient. So that means I have 2 amps there, 2 amps there. What do they want me to find? I'm actually done, because I'm going to use power equals I squared R. This is actually, when they're asking me to find power, this is the one I'll use the most, because I don't have to waste my time finding the voltage. I could, but I'm good to go. It's going to be, in fact, I can even do this in my head. In fact, I'll bet even Caleb can do this in his head, because it's going to be 2 squared times 5 in your head. 20 watts. Now, if you found the voltage and you went V times I, you would also still get 20 watts, but I got there in less work. So 4 out of 4 if you have that. Otherwise, for part marks, I would probably give you 1 mark for that, 1 mark for that, 1 mark if I saw that you'd realize that 2 amps was the total current, and then 1 mark for going I squared R. And that I squared R is on your formula sheet as well, yes? We did V times I, and then we plugged in V equals I times R in, and so it's also I squared R. Eric is looking. It is. Yes? Okay. Eric, what did part B want me to find? Oh, is it using principles of physics? Yeah. Oh, cool. Suppose the 4.5 ohm resistor is removed. Okay, so in my mind, I'm going to write on this. I wouldn't. Don't do this on your diagram, but you're telling me that's my new circuit. A 16, a 9, and a 5. In series, I could solve that. I would go 16 plus 9 plus 5. I think that's 30. Yeah? And I could find my new current. But let's see if I can, and if you do that, I'll give you full marks. Let's see if I can do this intuitively. So the bulb is brighter, dimmer, or unchanged. Removing R in, when you add a resistor in parallel, what happens to total resistance? Decreases. So when I remove a resistor in parallel, even though you might think, well, aren't you removing a resistor? Increases R total, which increases I total or decreases I total? And then I could say, since power equals I squared R, this is why that version is so handy. The resistor hasn't changed. That's a physical property of the actual bulb or device. What has changed? Power equals I squared R. So power has decreased. Dimmer. Anybody crunch it? What do you get for the new wattage if you actually crunched it? Nobody crunched it? Wow! I'm impressed. I'll do it really quickly here. It's going to be 16 plus 9 plus 5. 16 plus 9 is 24 plus... No, 16 plus 9 is 25. It's 30. Okay, so it's 30 ohms. Our total is 30, so 48 divided by 30 equals 1.6 squared times 5. 12.8. I'll put in brackets 12.8 watts if calculated. For you to get full marks then, you would circle dimmer. That gets you 1 mark. I would give you a half mark for saying R total increases. I would give you a half mark for saying I total decreases. And then I would give you 1 mark for saying power got smaller. That's why we're dimmer. Is that okay? Can you give yourself a lovely score on that quiz out of 16, please?